Hey everybody, this is Larry. This is day 29, almost the end of the January Leetcode Daily Challenge. Hope you're having a good month. Hope you're having a good time. Um, yeah, stay safe out there. Hit the like button, hit the subscribe button. Join me on Discord. Let me know what you think about today's problem. Vertical order traversal of a binary tree. Yeah, so usually do these live. And what that means is that I do the explanation and dot process live. So if it goes a little bit slow, just fast forward. But yeah, remember to I get a lot of questions about whether I get burnt out as well. I might have talked about this yesterday or the day before, but I just I do these for fun. It only takes about 10 minutes or whatever. It's not super stressful. Um, like most people do crossword puzzles. I think the biggest part about these things is learn to pace yourself. Don't get burned out, and just understand that whatever you see me do, I've been doing this for 10 plus years, maybe closer to 20 years now actually. So definitely, it's not going to be fair, quote unquote. But why I do these is that I want to show not just the ideal happy path case of someone being able to solve all these, but also that even someone who has been doing this for a long time and is probably pretty good for the most part, if I am a little bit arrogant to say that. But even then, I struggle from time to time. So and like make silly mistakes which you point out in the comments, which I appreciate, or someone like that, right? So it's okay. I mean, it happens. All you can do is just um, try your best, and everything else, it's a little bit of luck, it's a little bit of whatever. And if you buy enough lottery tickets, all you need is to win once, right? Okay, so today's problem, after that long intro, is the vertical order traversal of binary tree. Given the root of the tree, calculate the vertical order traversal. What does that mean? Left, right, notice this thing. Vertical is a list of non-empty reports. For each report is a list of all nodes from given x coordinates. Come again? Okay, so it just goes from left to right. Three. Oh wait, no. I thought it was vertical. Okay, so then it goes 9, 3, and 15, 20, and 7. Okay, that sounds reasonable. The report should be sorted by y coordinates, and from the highest y to the lowest. Which one is y again? Oh, so it should be sorted by the earlier and then the lowest. And if they're the same, then the nodes of the smallest y should appear earlier. That's a wow. I mean, there's nothing really conceptually tricky about it. I think when I see this problem, it is just depth first search, or maybe breadth first search if you like. And then after we put everything in the X together, we can just sort by Y. I think that should be good enough. And after that, it's just implementation. Why do I know depth first search is good enough? Because it is just going to be linear. So I don't really have to look at constraints, though there's going to be sorting of some sort, but even in the worst case, it's going to be n log n if any with any sorting. I think one thing that I might think about is just maybe I could do without sorting, but it seems and maybe on an interview this is what I may ask about, whether that I need that this is good enough, because because I actually don't know if you could do it without sorting. Maybe if you're really, really careful and you can look at the last few numbers in a good way, but I don't know if I am convinced that that is good enough due to the number of possible overlaps at the same location. Because it seems like you could have multiple overlaps, and from that, if you have to kind of have an ordering between them, you have to sort at some point. So, but yeah, okay. So yeah, so I think what I'm gonna do is, yeah, I mean, I'm going to use like hash table for lookup just because I'm a little bit lazy. But you can probably do something else. So let's just say X's maybe is equal to collections dot. Because why I say this is that it's going to add sorting here that I'll show in a second. While if you're able to, you could use an, because we know that this is going to be a complete array. You can actually just use an array of an array or a list of a list or something like that. However, it's just more annoying to get right, and the potential like wraparounds off by ones and stuff like that. But if I do it this way, then at least it will require some sorting of the keys, but I don't have to worry about it that much on implementation. So then here we're going to do a depth first search, or I call it depth first search, but it's actually let's call it in order traversal. I mean, it doesn't really matter if it's in order or post order, pre-order, because we're going to sort it later anyway. But let's call it pre-order then. And then we have the x coordinates, y coordinates, and then just the node, or maybe the node first. I think that seems more thematic. Yeah, and then here we do the pre-order, which is xs of x append, and then we just have the y coordinate, the node dot value, and I guess that's it. I was going to also put in the node, but I don't think we need the node if we already have the value. So then, oops, after the pre-order, we have to do pre-order node dot left, and it is x minus 1, y plus 1, right? Is that right? Like, that's really weird that we have negative positions. That's why I'm a little bit scared, whatever, but okay, fine. So same thing, but with the other one, and let's just do node is, we return so that we don't process it. And then we just do a pre-order on the root. 0, 0 is the first index, and then now we can do something like for each keys. Well, we want to sort the keys, and then for key in the sorted keys, the current list is equal to this thing, say. Also, we have to return the results. Let's just call it an answer array. So this is the current list, and of course this is going to be the smallest number, so it's going to be the first one. And then now we want to sort the current list. Yeah, and because of the way that we do the tuples, this should already sort by y, like highest y coordinates first, and then the lowest. Okay, so actually what we want to do then is put this as negative y so that we get the largest when we sort it, and then wait, what is the number? The smaller value first. Okay. Yeah. Okay, so that's good. Now we have the values, so actually we can actually do this because it's the same, and then now what is this actually, right? For well, the y value and then the actual value in this, we want to just get the value, so then we can actually underscore this, and then we convert this to a list, and then answer can append it, and then we could just return the answer. And you could actually even do this in one line if you're really clever. I'm not gonna do it, but I think this should give us a good start. Yeah, and it looks okay, so let's try the other test case, and this is a full tree test case. It should be okay. Let's kind of give it a look. Anyway, looks good, so let's give it a submit. Yay. So what is the complexity? As we said, the pre-order is going to be just a regular traversal, so this is linear in the number of nodes. The two sort we do is that we sort by each x number, so that's going to be also, I guess, what is the worst case of this? I guess the worst case is still going to be like a SNCC type thing, and then you have to sort like half the tree, so that's going to be n log n in either case, right? So this is n log n all in total. yeah, and of course the keys, there could be n log n keys, so it still should be n log n in total, I believe. And in terms of space, this is linear space because each node has one item in this dictionary, and also one item in the answer. So yeah, so linear space, n log n time, and that's all I have. I Let me know if you could do this in linear time. Let me know, because I'm curious. But if this is a contest or something, this is definitely what I would do because this is just so short and concise. And yeah. Let me know what you think. Let me know what you think about this problem. Yeah, again, I hope everyone's doing well. I hope you're taking care of yourself in this time. Take care of others if you have a chance. Stay good, stay well, stay healthy, to good mental health, and I will see you tomorrow. Bye bye.